Hi, this training session is intended to speak a little bit about remote sensing in general. Remote sensing normally are done with satellites, and these satellites are platforms with sensors, specific sensors that are observing the Earth continuously. So I would like to speak about two satellites of the European Space Agency that are managed in a program that they are called Copernicus program. So two satellites that I would like to speak to you are that normally we use for our technology, beside others, are the Sentinel-1, that is a sensor, it's a radar sensor, and the Sentinel-2, that is an optical sensor. Let's start for the optical sensor on the left side. So the optical sensor depends from the sun, depends from the radiation of the sun. So this sensor normally is called a passive sensor because it does not emit radiation, the satellite himself, and depends from the radiation of the sun. So the only images that this satellite can capture is during the day. So because we have radiation during the day, so we can measure the radiation that is reflected, absorbed, or transmitted by the objects in the surface of the Earth. On the other side, there is the radar satellites, for instance, and the Sentinel-1 is not a passive sensor; it's an active sensor. So this one does not depend from extra energy sources. This one carries a specific source of energy that emits towards the surface of the Earth, and then measures the reflectance, let's say the retro distribution, back to the satellite, and considering the pattern of these reflectances, they can infer about what is happening on the Earth. So the optical satellites normally depends from the light of the sun, and as you may know, the light of the sun is divided in different colors, let's say different types of radiation. And different types of radiation are interpreted by plants differently. For instance, a plant that is vigorous, that is healthy, normally reflects a lot on the infrared, near infrared, and absorbs a lot in red. The plant that is not so healthy does not, these differences is not so high. And so a plant that is more or less dead, it's even lower. So depending on the reflectance of the plants in terms of specific radiations, we can calculate indexes, and these indexes can give us an idea about what is going on parcels on Earth. About the right one, the radar satellite, the Sentinel-1. So it's more or less the same, but this is not depending from, let's say, the concentration of chlorophyll or whatever, but this depends from the structure of the soil occupation. So high trees normally reflect more than small trees. So large leaves normally reflects more than small leaves. And the density and the height and the type of branches, the number of branches, the orientation of the leaves, etc. In certain way condition the reflectance to the satellite. So this satellite measures, let's say, textural in terms of textural indexes. So it's the texture of the canopy of the vegetation or other type of objects, and these measure the structure, let's say, of the vegetation. And the complexity is a little bit more higher depending on the wave, etc. that is used by the satellite. But more or less in a simple way, it's like this: that these two satellites works for our use. Okay, so let's give you an example. As you can see here on the left picture, we see corn, and we see different heights of corn. And corn, let's say here, that shows a little bit of the soil because the plants are smaller, and here normally the soil does not appear on the image. On the right side, you can see a photo where more or less the plants are more or less the same, let's say height and density, but there is a particular area here that the plants are dying, or the color of the plants are different from this one. So let's see if we can use these for the two satellites. Can we use those satellites in order to detect this type of differences, the structure problem, and also texture problem, and also the texture problem than the structural problem? Is it possible or not? Okay, I think yes, it's possible. Let's hear more on next videos in order to see what we can do with this.